Saxon's Calculus Lesson 100 is about particle motion for the fourth time. Now I've gone ahead and jumped to example 1 where they give me the velocity function for a particle moving from left to right along the x-axis is given v of t. And then the following integrals were given. And so you can see that when it went from 1 to 2, I got a -7. From 2 to 3, a 3. From 3 to 4, a -2. And from 4 to 5, a 6. In part A, it says, how much did the position of the particle change during the interval going from 1 through 5? Well, that's just a matter of taking each of these answers and adding them together to see how much they've moved. And you see that when we do that, we get our -9 plus 9, and so we get 0. So the net change is 0. So for A, 0 is the answer. Now for B, it asks, if the particle was at x equals 7, when t equaled 2, what was the position of the particle when t equaled 4? So I need to look and see that when it's moving from 2 to the 4, it went 3 to the right and 2 to the left. And then it said that we are beginning with an x equals 7. So 7 plus 3 is 10, minus 2 is 8. So we are at x equals 8 when the t is 4. That's the other answer. Do not have room. Let me flip the page. So example 2 says, a particle moves along the x-axis so that the position function is, and I've gone ahead and written the equation out. Part A says, what is the position of the particle when t equals 0 and t equals 3? So first we're going to plug in the 0, and of course that very quickly gives us a 1, no problem. And then when we plug in 3, that's a little bit trickier, but 3 cubed, 27 times 2, and then minus 9 times 9, so 81, plus 36 plus 1. And again, you're going to do that on your calculator. So that answer comes out 10. Now, part B says, what is the distance traveled when you go from 0 to 3? So in the problem, they go through this very long explanation that has to deal with the different sections divided between 0, 1, 1, 2, 2, 3, and 3 forward. And it goes from positive to negative to positive, positive. And then they do some integration and they manipulate. But there is a faster way past all of that, which they finally get to, where they tell you that since going from 0 to 3 gave us the answers of 1 to 10, and that's increasing, then we are basically combining those distance traveled between. So 1 is the first distance, 10 is the second distance, so the total distance would be 11, so units. So don't complicate things if we don't have to. And then example 3. The acceleration of a particle moving on the x-axis is 4 pi cosine t. If the velocity is 1 at t equals 0, what is the average velocity of the particle over the interval between 0 and pi? So we are going to integrate to find that average velocity. Okay, that's what I thought. So we're integrating. The 4 pi is considered then a constant in front. So we're just integrating cosine of t dt implied there. So that's going to go to 4 pi, and cosine goes to sine of t plus c because we integrated. And then we need to plug in that they gave us a 0 yielded 1. So when I plug in 0, the sign at 0 should be 0. Yes, 0 times something is 0. So 0 plus what equaled the 1 that they provided. So that means that C is 1. So now our velocity formula would basically say 4 pi sine of t plus 1 rather than the plus c. Is that all they wanted? What is the article over this? All right, no, it's not, because they're looking for the average one, which means we need to do I need the 1 over top of the subtraction. No, sorry. I'm not saying that correctly. It's not the 1 over top of the subtraction formula because it's looking for average. I need to do the distance between the answers and over top of the subtraction of their time. So their time is being used as the 0 to pi. So pi is the larger, so pi minus the 0, that's just going to be pi. And then in the numerator, we are plugging in 2. Yes, okay, so it is the integration of this formula. That's why we found this velocity formula. So I need to integrate up here. So that's going to give me, sine goes to negative cosine. So negative 4 pi cosine of t plus, and it used to be, so because it was plus 1, that's now plus t. And then we are plugging in that same 0 to pi. Then the 0, cosine of 0, that's 1. Negative 4 pi plus the 0 would be negative 4 pi. Plugging in pi, okay, that's your 180 line. And so when you're doing cosine, starting at the top, pi over 2, so that's down to its low point. Just a second, the negative. Negative means I'm starting here. So it should be the positive point of 1. So that should end up being pi. I don't feel like I'm thinking my way through that right. Hang on a second. Okay. I caught what I did. I was right the first time, and then looking at this negative made me mentally flip the graph. And when you're doing it on the calculator, you won't have that problem. You're just going to straight up plug in and then what I did here was when I said I did the 0 one, I ended up with the negative 4 pi over pi. I didn't write this part. And then I'm going to scratch this because that's the 0. It's the part that's minusing, so I'm going to change that to a plus. And then I needed to get the answer for filling in the pi. And so on your calculator, that gives you negative 1, which I first started to say for the cosine. So that makes it positive 4 pi plus the pi, giving you 5 pi over pi. And then the common denominator there is going to be 9 pi over pi. And so the pi's cancel off. I could have done that here either way. I'm ending up with 9 units, but since this was velocity, it's per second. Now, example 4. The velocity function for a particle moving left to right along the x-axis is given by v sub t equals 2 pi cosine pi t. For what value of t that has to fall between 0 and 2 is the not moving? So I need to set the velocity equal to 0, and my 2 pi is considered a constant. So ignoring that, And dealing with the pi over t part here, that's obviously a number, so that ends up being pi over top of, and I need to remove the 2, so it's going to be pi over 2. So I'm basically trying to set then pi t equaling to the pi over 2. So that means the t would be a half. It would also occur at 3 pi over 2 and 5 pi over 2. Because if I'm picturing that in my 4-quadrant grid, those are the next places where I end up equaling 0. And then only 2 of them fall in the boundaries given, which was between 0 and 2. So that is, of course, my 1/2, and the next one, which was 3/2. And I don't feel that I finished explaining how I got to the 3/2, because every time I'm going around the 4-quadrant grid, I get to the same 0 place if I'm adding pi. So if I add pi to this, I end up with the 3 pi over 2. That's how we got there. Example 5. What is the total distance traveled to the left by the particle in example 4? Okay, so we knew that we had zeros at 1/2 and 3/2. So if I picture that at 1/2 and 3/2, and it was cosine, so it was starting above, and I'm hitting zeros here and here, then it's got to be doing, oops, that should have been in the middle. It's got to be doing that. So what is the total distance traveled? So I would need to integrate from that 1/2 to the 3/2, and the formula in the other equation was cosine pi t, and then what is its matching? The 2 pi was there. Okay, so it's multiplying with the pi, but the 2 is the constant moving outside. Let me check that original equation again. 2 pi with cosine pi over t. Yes, okay. So, and my dt. Okay, so now 2 is going to be multiplying with, and when we integrate cosine, we go to sine of pi over pi t. Irrelevant. So then plugging in from my 1/2 to my 3/2. Yes. Then again, calculator that, because that's getting a whole lot harder for me to picture those graphs in my head. And it should be spitting out for plugging in the 3 over 2. That's sine of 3 pi over 2, -1. I should be getting this +1 for plugging in the pi over 2. So since I'm subtracting those, I'm doing 2 then with -1 minus 1, and that should be -4. The negative sign on the integral indicates that the area is below the x-axis, yes, and that the particle moved 4 units to the left when it went between 1/2 and 3/2. Yep, so as long as that makes sense to you, we're good.